Have you ever looked up at the night sky? Those twinkling lights are stars, distant suns, each a massive ball of hot gas. Some are smaller than our sun, others are unimaginably huge, and together they form the backbone of galaxies like our own Milky Way. We're just a tiny part of this cosmic neighborhood. Stars aren't eternal, they're born, live, and die in spectacular ways. The death of a star is one of the universe's most dramatic events, sometimes outshining entire galaxies. Understanding how stars die reveals the origins of everything: the atoms in your body, the air you breathe, the ground you walk on. So what really happens when a star's light goes out? We're about to journey through the life and death of stars, how they shine for billions of years, and what happens when their fuel runs out. This process creates some of the strangest objects in the cosmos, like black holes and neutron stars. The end of a star's life is actually the beginning of something new. By the end, you'll see the night sky not as a static backdrop, but as a place where creation and destruction are always at play. This is our origin story, written in the stars. Get ready to dive into the heart of cosmic explosions. Consider this. So what is a star? At its core, it's a giant ball of hydrogen and helium held together by gravity. Stars are born in vast clouds of gas and dust called nebulae. Gravity pulls this material together, heating it up until nuclear fusion ignites. A cosmic campfire is lit. Fusion in the core slams hydrogen atoms together to form helium, releasing immense energy. This energy pushes outward, balancing gravity's inward pull and keeping the star stable. Our sun has been shining this way for about 4.6 billion years. Think of a star's life as a long-burning candle. As long as there's hydrogen wax, it shines. This stable phase is called the main sequence, where stars spend most of their lives. Smaller stars burn fuel slowly and can live for trillions of years. Massive stars burn fast and die young. A star's size determines its color, temperature, and ultimate fate. Our sun is a medium-sized yellow star, steadily converting hydrogen into helium. But its fuel won't last forever. Every second, it fuses millions of tons of hydrogen. Eventually, the hydrogen runs out, and the star's final act begins. That's when things get really interesting. When a star runs out of hydrogen, fusion in the core stops and gravity takes over. The core collapses and heats up, igniting a shell of hydrogen around it. The star swells into a red giant. Our sun will do this in about 5 billion years. Its outer layers expand, possibly engulfing Mercury, Venus, and even Earth. The surface cools and glows red. Inside, the core gets hot enough to fuse helium into heavier elements like carbon and oxygen. This phase is brief compared to the star's main life. Once helium runs out, the star's fate depends on its mass. For stars like our sun, gravity can't fuse heavier elements, so the star becomes unstable. It puffs its outer layers into space, forming a glowing planetary nebula, a cosmic smoke ring. The leftover core becomes a white dwarf, Earth-sized, super-dense, and slowly cooling. No more fusion, just a hot ember fading over billions of years. Eventually, it becomes a cold, dark black dwarf. This is the quiet end for stars like our sun. But for bigger stars, the story is far more explosive. Massive stars, at least 8 times the sun's mass, end with a bang, a supernova. These giants burn through their fuel quickly, fusing elements all the way up to iron. But fusing iron doesn't release energy, it drains it. When the core is iron, fusion stops, and gravity wins. The core collapses in a split second, shrinking to just a few miles across. This triggers a shockwave that rips the star apart in a titanic explosion, a supernova. For weeks, it can outshine an entire galaxy. Supernovas forge elements heavier than iron, gold, silver, uranium, and blast them into space. The expanding debris, called a supernova remnant, enriches the galaxy with the building blocks for new stars and planets. The Crab Nebula is a famous example, a cosmic monument to a star's explosive end. Supernovas are rare, but they shape the universe. They're the ultimate cosmic fireworks. After a supernova, what's left depends on the star's mass. If the core is between about 1.5 and 3 times the sun's mass, it becomes a neutron star, an object so dense a teaspoon would weigh 1 billion tons. Neutron stars spin rapidly and shoot out beams of radiation. If these beams sweep past Earth, we see them as pulsars, cosmic lighthouses. Pulsars are some of the universe's most precise clocks, but if the core is even more massive, gravity crushes it into a black hole, a point of infinite density. Black holes have gravity so strong that not even light can escape. The edge is called the event horizon, the point of no return. We can't see black holes directly, but we detect them by their effects on nearby stars and gas. Material spirals in, heats up, and glows before vanishing forever. Black holes are the universe's ultimate enigmas, the final fate of the most massive stars. These remnants, neutron stars and black holes, are the most extreme objects in existence. They warp space and time, challenging our understanding of physics. The death of a star leaves behind cosmic monsters, and they're out there, shaping the universe. Let's compare two stars, our Sun and Betelgeuse. The Sun is a medium star halfway through its life, shining steadily. In 5 billion years, it will become a red giant, engulfing the inner planets. It won't explode. Instead, it will shed its outer layers, forming a planetary nebula. The core will become a white dwarf, cooling quietly for trillions of years, a peaceful end. Betelgeuse, on the other hand, is a red supergiant, huge and massive, about 15-20 times the Sun's mass. It's lived fast and is already near the end of its life, just 8-10 million years old. Soon, Betelgeuse will run out of fuel, its core will collapse, and it will explode as a supernova. When it does, it will shine brighter than the full moon, visible even during the day. It's too far away to harm us, but it will be a spectacular sight. Afterward, Betelgeuse's core will likely become a neutron star. Two stars, two destinies, one quiet, one explosive. The universe is full of such stories. The death of a star isn't just destruction, it's creation. When stars die, they scatter elements like carbon, oxygen, and iron into space. Supernovas go further, forging and spreading even heavier elements: gold, platinum, uranium. This stardust mixes with gas clouds, forming new stars and planets. Our Sun is a second or third generation star, born from the ashes of earlier stars. That's why Earth has the elements needed for life. Every atom in your body heavier than hydrogen and helium was made in a star. As Carl Sagan said, we are made of star stuff. The cycle of stellar birth and death makes the universe dynamic and alive. Without dying stars, there'd be no planets, no life. Next time you look at the stars, remember, you're seeing the factories that built you. The death of stars plants the seeds for the future. We are children of the cosmos. Why does the life and death of stars matter to us? It's the story of where we come from and what we're made of. Studying dying stars lets us test physics in the universe's most extreme environments. We can't make black holes in a lab, but the cosmos does it for us. Observing these objects refines our understanding of gravity, matter, and energy. It also helps us predict the future of our solar system. Our Sun will become a red giant in 5 billion years. This knowledge gives us perspective. Our world is precious and fleeting. Learning about the cosmos connects us all, no matter where we are. The quest to understand the universe is a shared human adventure. It sparks curiosity, fuels imagination, and reminds us we're part of something vast. The story of dying stars is about creation, connection, and our cosmic origins. And that's a story worth knowing. The death of a star is not an end, but a transformation. These cosmic events create the elements that make up everything around us. Without generations of stars living and dying, there'd be no planets or life. A star's mass decides its fate. Small stars fade quietly, massive ones explode. The light from dying stars travels across the universe, telling their story. When we look at supernova remnants, we're seeing history written in stardust. It's cosmic archaeology, uncovering the secrets of our galaxy's past. Next time you gaze at the night sky, remember, every star has a story. Some are just beginning, some are ending, and all are part of a never-ending cycle. The stars are our cosmic ancestors. Their story is the story of the universe and of us. Consider that.